So in the last video, we looked at part one. We looked at how to what the relationship was between these various parts of the ellipse, A, B, and C, and if we were given these specific A, B, and C locations, then how we could find a missing one and how we could graph it. We're going to now take a look at the equation and how by looking at an equation we can find all of these parts A, B, and C. So if you look here on the left here, we have the basic standard form of an equation of an ellipse. Now, let me give you a few pointers here. On an equation of an ellipse, it's always going to equal 1, first of all, and the a and the b are found underneath the x and y terms. The a squared is always going to be under the a squared is always going to be the larger number on the ellipse. Okay, it's different. It's different for the hyperbola. We'll look at that in the 7.3 section. But this a squared is always going to be the larger number. And what do we know then? When we find the larger number, we have found the major axis. In other words, the orientation. Okay, or the orientation of the ellipse. So because I'm just going to tell you that this A is the larger one, because I'm about to show you the numbers over here, but if this A is larger, that means that this graph, the ellipse, is oriented in the x direction, meaning it's longer in the x direction. That's where the major axis is. Okay, so on an ellipse, you're going to look for the larger number in the denominator, and that's going to be the orientation of your ellipse. So if we were going to build an equation just from this picture, we were going to build an equation using our template here of the standard form of an equation of an ellipse. Here's what we would do. We would say, okay, A in this picture is 10, so I'm going to put 10 squared. Oops, sorry about that. I'm going to put 10 squared on the bottom of that fraction. B in this picture, remember B was, what, 8? So we're going to put 8 squared down there. The whole thing has to equal 1. Now on the top, what we have is similarly to the circle. Okay, had to pause really quickly, and I can't remember where I left off, except let's continue with the formula. In the numerator of each of these terms, we have information about the center of the ellipse. And here's what I mean. I'm going to go ahead and put a black dot right at the center. Well, the center of this ellipse would be at 0, 0. So if that's the center, then we know that that's what we call h and k. And the h and k show up in the formula right over here. Now we'll point out that the formula owns a minus sign right there. So when I'm actually putting in numbers, I need to let the minus sign be part of the formula and not part of the number. So if I'm putting in a negative, then it would be negative, negative, and you'll adjust accordingly. So there we go. X minus 0, there's the h, that's the x coordinate of the center, and then y minus k. So on this particular equation, this would be the formula. It would be x squared. No, x minus 0 is just x. So x squared over 100 plus y squared over 64, and that's equal to 1. So there's the equation for that ellipse. Okay, so let's use that information, that understanding, and let's go ahead to a new question, which would be to just graph an ellipse from the standard form of an equation. Alright, so let's take a look, and remember, the formula says wherever the big denominator is, that's the orientation of the ellipse. So this is the larger number, and so I know that that's my a squared. So my a squared is 36, which means, therefore, my a is 6. Well, here's the smaller number. B squared is 25, therefore b is 5. So I know my A and my B. So now I look up here to see where the center is. And if I don't see a number in the X and the Y term up there, then I know that my center is at the origin. So let's put the origin on here. And by the way, they want us to find the foci afterwards, but that won't be a problem, especially when we have our A and B. All right, let's take a look at putting our A on. A is 6. That means I'm going to go horizontally 6 from the center. 1, 2, 3, 4, 5, 6. There's the outermost part. 1, 2, 3, 4, 5, 6. Here's the outermost part on the left. And in keeping with the theme there, the B is 5. 1, 2, 3, 4, 5. I'm going to put a, oops, oh dear, I just went too many. There we go. 5. There's the outermost part. 1, 2, 3, 4, 5. Okay, so now we have the basic parameters really for our ellipse. So I'm going to go ahead and sketch it with a smooth curve connecting everything, and then I'll find the foci, whatever they are. Okay, good enough. Okay, so let's take a look. C squared is equal to A squared minus B squared. There's the relationship. So C squared, C is what I don't know. I don't know what C is, right? So C squared is equal to 36 minus 25. C squared is 11. C then is the square root of 11. All right, now I will put this in here for those of you who need to see all the steps. There's that, but I'm choosing the positive because it's a distance. So I choose the non-negative version because it's a distance. Okay, so square root of 11. Let's see, we need an approximation. When we name the foci, we're not going to use an approximation, but when we need to graph it, of course we have to use the decimal approximation. Remember that. So we have 3.3-ish. So let's go out 3.3-ish. And we'll be through putting our foci on. 3.3, yeah, 3.3-ish. So there's a focus. 3.3. And there's another focus. Okay, so now we've actually plotted the foci, but it says find them. And what I want to do is I want to give the location of the foci. I want to do that in an exact form. So let's take a look. I don't want to say, okay, it's just 3.30. What I'm going to put is positive square root of 11, 0, right? Because it's just coming out that far. Now I can go ahead and say plus or minus because that's the case for this other one here. It's just the negative version of square root of 11. So in this case, when the center is just right there at the origin, it's real easy to tell where the foci are located. Where each focus is. We're going to take a look at one more example. And we're going to graph this one. Now this one actually has a center that is off the origin. So here's this one. Let's take a look at this. So the first thing I'm going to do is I'm going to locate the center of my ellipse. Well, we know that this is H and this is K. Okay, so if the formula owns the minus, then the actual H that had to have been substituted in there was just a plain old 3. However, because we know that the formula owns a minus there, then they must have put a -1 in there for it to change the sign to plus. So that's how I know where my center is. So let's go ahead and put the center on my picture. 1, 2, 3, -1. There we go. All right, next thing I'm going to do is find the A and the B. Well, here's my larger denominator, so I know that this is my A squared. So A squared is 64, therefore A is 8. And this is my B squared is 25, and therefore B is 5. So I'm ready now. Once I have the center, I'm ready to go in each direction. The A, now which direction am I going? This is oriented horizontally because the large one is underneath the X. Okay, so here I go 8 out from that. 2, 3, 4, 5, 6, 7. Oops. There's that. There's the outermost part of that. the outermost boundary there. And the B, 1, 2, 3, 4, 5. And you may be saying, Miss Savelle, why are all of these oriented horizontally? Well, I did that on purpose. The next video will show you the vertically oriented ones. You just need to get this stuff down, and then it's a real easy transition to the vertical. Real easy to tell which way it goes. Just remember, the A is always on the same axis as the foci. Okay, whether it's oriented horizontally or vertically. Okay, whoops. Alright, did I miscount that? 5. Yes, I did. Sorry about that. Let's recount that top one. It looked a little skinny up there. Wait, 1, 2, 3, 4. Yep, I did. Here we go. Now, and that's a really good self-check as well. I mean, yeah, it's just the picture, but I do want to make sure that these numbers are correct and that they look correct. Okay, 1, 2, 3, 4, 5, and from there 1, 2, 3, 4, 5. Remember, it's from the center, which is that place right there. Okay. Now, let's find the foci. So we're going to go with c squared is equal to 64 minus 25. That's the a squared minus b squared, right? C squared is equal to 39. I'm going to bring myself room here. Then I'm going to take the square root of both sides, and I'm going to choose the positive. And it's actually, I'm going to go ahead and say that's roughly 6.24. 6.24. So c is the square root of 39 exactly, but roughly it's about 6.24, so let's put those on there. Now careful, that's 6.24 from the center. Here we go, to the right. 1, 2, 3, 4, 5, 6.24, so 6 1/4-ish. And then the other direction, 1, 2, 3, 4, 5, 6 1/4, roughly. Now there are the foci. Here's the deal. I need to name them properly. In other words, I'm not going to use decimals. I'm not going to I can't just say it's plus or minus 6.24 comma 0 because they're not on the x-axis. Okay, so let's take a look at where these foci are. And you'll see the pattern. Here we go. So I know that I need an additional 6.24 past the origin. Past where my center is. The center is 3 to the right of the origin. So what I'm really wanting is to say, okay, the C plus the 3 that I had to go to get to my center. So really what I'm saying here for this focus right there that's inside on the right, I'm saying the square root of 39. I want to put the exact number, and I'll say plus 3. 3 plus the square root of 39 is going to give me what we have there, which is 9.24. So there's the first point. So stop and convince yourself. It's 3 plus the square root of 39. That's where that focus is located. Okay? So here we go. The other one, okay, is 3 minus the square root of 39. Now let's see why that's the case. Well, this is 3 minus roughly 6.24, and wouldn't that give me the negative 3.24, which is the location of that one? Okay, oops, sorry, I totally forgot to put the negative 1 in there, my bad. So that is at negative 1, because we have to go down. We have to go down 1. But do you understand this? Because this is 6.24, we have 3 minus 6.24, which is the negative 3.24, and that's the location of that's the x direction, negative 3.24, and then of course we have to go down negative 1, which is why we have to write the negative 1. Okay, so I hope that's helpful and helps you understand how to find the actual location of the foci, locations of the foci. Thanks for watching.